Hello.
Good evening, sir.
Yes. Good evening, Shrestha.
Yes, sir.
Yes. Please introduce yourself.
I'm Shrestha Gautam. I'm from Ranchi, and I'm working as civil engineer here.
Okay.
In,
Okay. Okay. So you're working in a private firm.
yes, sir, in private firm.
Okay. Okay. So how did you feel about the first week's lecture? Was it useful?
They're very useful, sir.
Okay. Okay. So anyone else would like to volunteer?
Good evening, everyone. Myself, Sulaskati. I am from Nepal. Currently, I am working as a civil engineer professional in Japan. So, week first was really helpful and it was very informative. I'm looking forward. Thank you so much.
Yes. So presently you are working in Japan, is it?
Yeah, I am currently working in Japan.
Okay. Okay. That's nice. Okay. Okay. Anybody else would like to introduce?
Good evening,
Good
sir.
evening, sir.
Yes, sir.
Yes. Please, one of you go ahead. Maybe Anand.
Hello, sir.
Yes. Good evening. Hello.
So I am from Goa.
Okay.
I am studying in the third year in Goa Engineering College.
Okay, okay, okay. So, have you done any preliminary course on reinforced concrete design?
Yes, sir. I have done the basic course in design of reinforced concrete.
Okay, okay, okay. I think there is only one course, isn't it, or are there two courses?
So there is only one course,
Okay, okay.
but it is very old, 12 years old.
Oh, okay, okay, right. Please, Rahul, go ahead.
Good evening, sir. Myself Rahul from Pune.
Okay,
Actually, I was completed my B Civil Engineering, and now I'm a tendering and proposal engineer
okay,
in wastewater and environment engineering. Actually,
okay. That's nice. Okay.
Hello, sir.
Hello. Good evening.
Good evening. Myself Deepika. I am from Vadodara, Gujarat, and I am pursuing Masters in Structural Engineering at MSU Baroda.
Okay, okay. Nice.
Completed me from MS only.
Okay, okay. Nice to have you. Anybody else would like to introduce?
So myself is S.P. Sharma.
Yeah. Good evening, sir.
Yes. Good evening.
Sir, myself, Mohammed Williamson
Okay,
from Mumbai.
okay,
Recently, I have completed my degree this year only.
okay, okay.
Uh, yes, so that I am looking forward, like as a fresher. I am
Okay,
searching on a good entry level, like a good company.
okay.
And while searching the job, side by side, I am also doing this course.
Yes, yes. So I hope this course will be useful to all of you. I think maybe one of you can
Yes.
introduce yourself. Then we can start with the session.
Hello, sir.
Hello. Good evening.
I am from Gujarat,
Yes,
Bardoli, Surat,
yes.
and I am at present working as a lecturer in
Okay,
Diploma College.
okay.
Thank you.
Right. So how did you feel about the first week's lecture?
Very, very good sessions and very good informations which we are trying to transform to our students
Okay,
from this course.
okay. So thank you for joining, all of you.
Yes.
And I think there is a good mix of both those who are in academics, I mean both the students as well as the professors, and there are a few people in the industry also. So I hope that this course will provide you a better understanding of the reinforced concrete design. And we are going to start the session right now. Yes, I hope my screen is visible.
It's visible.
Yes, so I welcome you all to this NPTEL course on Advanced Reinforced Concrete Design, and the course is being instructed by Professor Surya Prakash from IIT Hyderabad. And welcome to the first interactive session. And my name is S. Nalit Sagar. I'm a doctoral candidate and PMR fellow in the Department of Civil Engineering at IIT Delhi. I did my bachelor's from Bangalore Institute of Technology, and then I did my master's at IIT Kanpur, and then now I'm pursuing my doctoral research under Professor Deeptharanjan Sahu and Professor Vasant Matsagar at IIT Delhi. So it gives me great pleasure to welcome you all to this course and be a part of this learning opportunity. And essentially this interactive session has been introduced so that first we are going to provide a summary of the lectures that you have seen in the past 1 week, and then we are going to solve some problems so as to gain clarity regarding the concepts. So the outline of the session would be such. So up to 7:30 we are going to take about 20 minutes in order to summarize the lecture slides, and then we are going to solve. I have framed around 15 questions for this present session. So we are going to take the questions one after the other, and then we can have discussions. And when I am discussing, please feel free to interrupt. You can unmute yourself and you can speak. And some of the students have raised concerns that the voice recording was not very clear. So if you have any questions, I welcome you all, because this is the right opportunity for all of you to solve any doubts that you have. And the best part is Professor Surya Prakash is going to be joining us at around 7:30. So let's make this a very interactive and enriching session. So I'll start with the summary. So we are going to take about 15 to 20 minutes in order to summarize. I hope that is fine, just to refresh our memories and better prepare for the question and answer session. Can any one of you confirm? Hello?
Yeah.
Yes,
Yes.
I'm going to be summarizing right now. So before that, I would like to have the opinion, if you're expecting anything out of this session, I'd like to, try to incorporate that also.
Yes, good evening,
Yes.
everyone. Thank you, Lalit, for hosting this, TA session. I really appreciate it. So, good evening, everyone. I am Professor Surya Prakash, and I am the lecturer for this course. I hope you're all learning something useful. So, really looking forward to having some very exciting assignments and creating new materials. And Mr. Lalit is one of the TA for this course. I hope he has already introduced himself. Right, Lalit?
Yes, sir, I have introduced myself, and I also told that you would be joining us. And it is a very good opportunity for the students to discuss with you and clear any doubts that they have from the week 1 of recordings.
Absolutely.
So yeah, kindly feel free to interact with Professor.
Yes, yes. Yeah, so please feel free to ask any clarification that you may have. Then I think I will request Lalit to share the keys, for the assignment 1. huh? As you know, this is a 40-hour module course. We have split them into 10 weeks. Each week has about content for about 3 hours, 2.5 to 3 hours, depending upon how it is. Sometimes it may be more also. So we have about 12-week content, right? So if I remember, I think we have about 40 hours of contents. So please feel free to watch them. And if there are any clarifications or if there are some mistakes also, please bring it to our attention, and we will be able to correct it for the future learners as well. Right? Yeah. Yeah, maybe I think it'll be good opportunity for us to, ask the attendees to introduce themselves. Yeah.
Yes, sir. I did for a few of them. So
Oh, very good.
it seems to be a mix of academic people from the academics and the industry.
Oh,
So
very nice.
yeah, if anyone wants to introduce,
Yeah,
please
if
feel
anyone
free.
has joined, recently, probably please feel free to, uh, turn your camera on. Just briefly introduce yourself. Don't be shy. I think Yeah, go ahead. I think Mr. Sist.
Sir,
Maybe.
myself S.V. Sharma.
Yeah. Hello, sir.
Sir, I am working in NHA projects as a consultant.
Very nice, sir. Very nice.
Actually, I know this NPTEL course very late. That is why I joined.
No
Otherwise, I
problem.
have joined very early.
No problem. So where are you working, sir? No, in consultant.
I am working in Karnataka, near Bengaluru.
In Karnataka. Very good, very good. Yeah, yeah. Now I think with so many projects are going to come also, I think whatever this
Sir, sir, your voice is not coming.
learning from this equipment. Is it audible now? Hello.
Yes, sir. Now it's
Yeah,
audible.
yeah.
Now I said, in spite of your professional commitment, it's good that you're joining. Very nice of you.
Sir, I have a special interest in this structural engineering. That is why I joined.
Very good. Very good. Very good. Thank you, sir. Thank you. Yeah, please keep interacting, and if you need any clarifications on the material, send out emails, which frequently will be answering it. So please participate well in the course, and yeah, thank you very much,
Sir,
sir.
I want to know. Sir, I want to know about this geopolymer cement concrete. Actually, there is no
Ah,
detailing anywhere.
hmm. Yeah,
That's why
geopolymer
only some
concrete.
papers are coming.
Correct. So see, because you need alkali activation is required, and handling is little difficult nowadays. A lot of research is happening, which at lower pH level also you can do the activate the fly ash. Okay, for precast application it is very much doable in a controlled way. Okay, and also you need heat. If you do it at with the thermal curing, then your the strength gain is also faster. So there are some challenges are there with the geopolymer concrete. But having said that, if you are able to do it in a precast environment, then it becomes very doable.
Highly preferred. So now
Yes.
it is using, sir, in precast concrete.
Yes, precast.
How is
There are
it?
there are factory product now. The geopolymer based bricks have come, and precast elements are also manufactured at several factories. But only thing is, the handling and all, you have to be careful, because you deal with the highly alkaline material, and also you need temperature for curing and so on. So cast in place construction, there are a lot of challenges, but precasting definitely it can be done.
Thank you, sir.
Thank you. Okay. Anybody else? I see a lot of people, Anand, Akash, Abhijit.
Yes,
Have
sir. I
you?
think 5, 6 of them have introduced. So maybe.
Very good, very good, very good. So anybody who would like to introduce, please feel free to do so. Okay. Well, no, I think Lalit, I think, Shankar, yes, go ahead. Yeah, Shankar. We're not able to hear you well, but Shankar, are you speaking? Hello, Shankar.
I think you have to unmute, Shankar. Please unmute yourself and
Probably his microphone is not working, and I'm not sure. Okay, no problem. Okay, so you just try it again. If there is anybody else who would like to introduce, please feel free.
Hi, sir. Good evening, sir.
Yes.
Hello.
Yeah, this is
Sir, my name is
Mohammed.
I'm
Yes,
Mohammed
yes,
Ilyas.
Mohammed, yes, tell me. Yeah, go ahead.
Yes, sir. Sir, I already introduced myself for Lalit, sir.
Yeah.
Uh, I, I am introduced Naufal for you. Sir, I have recently completed my BE from Mumbai University. Consume Islam Kalse ka Polytechnic Pani.
Mm-hmm.
Yeah, very recently, sir, I am searching like an entry level job
Mm-hmm.
for an industry.
Mm-hmm.
And while searching side by side, also I know about NPTEL, so
Mm-hmm.
that like uh, I joined this course for gaining some extra knowledge about the structures.
Very good. Very good. I think I appreciate your interest to
Yes,
learn more on the subject. See, this course, we directly don't go into
yes,
design, as you know. I think the focus would be more on, the fundamentals and behavior aspects so that, how to use the code and,
yes,
look at the numbers and then use it. That typically, we don't tell. We try to teach why certain provisions are there and
yes,
what is the limitations, and so in that point of view you have to look at it, because most of the times now people think that using software you have to teach. We don't focus on that, because using softwares like ETABS and STAD, you can do it by yourself. That a lot of YouTube videos are there, and you will be able to pick it up very quickly. So the focus is in this course, which not on that, more about the behavioral aspects. Once you understand the behavior, the design would be very straightforward, right? So you have to look at it. I appreciate again, your interest to learn. Hopefully, I think it will be very useful to you.
yes, sir. Thank you so much.
Thank you, Mohammed, for joining. Yeah. I see Mr. Subhash, Mr. Rahul.
Hello, sir.
Hi, Subhash. How are you?
I am fine. I have already introduced to Mr. Lalit, sir.
Very nice. Very nice. Okay.
I am Suras Karke. I am from Nepal.
Oh,
I
very.
am currently working as a civil engineer in Japan.
Oh,
So
very nice.
my objective from this course is to learn the behavioral aspect and learn the manual design process
Mm-hmm.
of reinforced concrete structure. So I have request, if possible, in these live interactive sessions, if possible, I would like to request to include the real life problems, real life designs of
Mm-hmm.
the reinforced concrete structures. Thank you so much.
Okay. Yeah, sure. I think there are a lot of problem solvings are already there, but maybe one tutorial session we would probably I'll request our TAs to conduct, so that step by step solving also we do it, right? For example, a column design or a beam design, right? So we've given it in the PPT slide because of the the time restrictions. Ideally, we teach them in board in the class, but now that we have to cover a lot of topics, so we were using PPT and then we were marking them as we go along. Because advantage with this thing is, you can pause the video and you can take notes and so on, so on. But what we can do is we'll have the regular TA sessions where the TA will solve the problem step by step. Then in that process, it will be much more easier for you to follow it, and you can get your the doubts clarified then and there. Yeah, we'll do that. Yeah. Thank you.
Thank you so much.
Thank you.
Hello, sir. It's me, Usabania Karki. I have also joined this session from different ID, but we are husband and wife, so we will join this.
Very nice, very nice. So, okay, I'm glad. So, you are also civil engineer with bachelor's. You are working in the same company, or?
No, I'm working in a different company as a civil structural engineer and doing structural design.
Very nice.
Company.
Yeah. So, which city in Japan you are from?
We work in Tokyo and living in Chiba.
Chiba, yeah, I know. I've been there to Tokyo. It's a beautiful, very organized city. So nice. Good luck. Some of my students are also working there. So good to see you. Nice. Thanks for your interest in the course. Yeah. Thank you.
Thank you so much, sir.
Thank you. Okay. Yes, go ahead. Yeah.
Yeah, good evening, sir. Myself Rahul Zada from Pune. Actually, I was completed my BE Civil Engineering in Pune, and I am now working as a tendering and proposal engineer in environment and wastewater engineering.
Very nice, very nice. Thank you, Rahul, for joining the course. Yeah. See, anybody else? Okay. All right. So, okay. So anyway, thanks once again for joining. I think I request now Lalit to, discuss the week one assignment and the solution.
Yes, sir. So I have prepared a new set of questions, sir, because the deadline for the submitting the assignment is 8th, I think 7th of August.
Oh, they have, so first week assignment is next.
Yes, sir. Yes, sir. So they have not yet
submitted. Yeah, then it's fine. Yeah,
yes.
You are prepared for this question. Yeah, well, go ahead then. Please go ahead.
Right.
Yeah. All right. Thank you.
Thank you for joining.
Then you take over the session. Yeah. And if there are any questions are there, again next week or maybe the week after, we will have a discussion on this. Yeah.
Yes, sir. Yes, sir. Thank you for joining. Okay.
Thank you. Please go. Thank you.
So welcome back all of you. So we have around 15 questions. So first I would like to have your feedback. Should we just summarize what has been done in the lectures for about 10 minutes before starting the questions, so that we can refresh our memory and the concepts?
For week 1, sir?
Yes, for week 1. We can summarize the lecture for about 10 minutes so that we can refresh the concepts. Or if you are ready to go to the question and answer straight away, we can do that as well. Okay, I need feedback from any of you. Hello.
So in the first week, sir, we learned about the
yes,
the overview of RCC, introduction of RCC.
Yes.
That is info, cement, concrete.
Yes.
And then the various design philosophies.
Yes. So what I can do is I will probably take about 10 minutes to revisit the concepts that we learned in the lecture of week 1, and then we can start with the multiple choice questions. So I hope that it will be a very interactive session. We have 15 questions, and before that let me just get started with the summary of the lectures. I hope my screen is visible to all of you. Sorry.
No, sir, it is not shared.
Yes, yes. So I'm sharing now. I hope it is visible now.
No, sir.
Oh, okay. Can you see the PDF now?
Yes.
Yes, sir.
Yes, sir.
Okay, okay, perfect, perfect. So, in the first module, we have seen the introduction or the overview to reinforced cement concrete. So, initially, we saw the history of concrete and reinforced concrete.
Sir, it is not shared and wires also breaking, sir.
I'm sorry, the voice is breaking, is it?
Sir, our screen is not displayed, sir.
The screen got.
No, sir,
Yes, I
Screen
think
not displayed.
it is okay only. I think it may be the internet connectivity at his end, but
Okay, okay.
it's
Right, sir. I'll better switch to another source, maybe. So, is it visible now? Hello? Hello, can anyone of you volunteer?
so screen is not, changes is not coming directly.
Yes, sir, it's fine now.
Is it fine? Okay.
Yes, sir.
Okay, sir, I hope it is
Yes, sir.
visible now.
yes, yes,
Okay,
slides
okay.
are visible.
Right, right, sir. So, we first saw the history of concrete and reinforced concrete. Then we saw the different types of RC systems, structural systems. Then we discussed the advantages and disadvantages of RCC. Then we saw the influence of cement production on the sustainability, because environmental sustainability is a very important topic these days. Then we also discussed about the future of cement concrete construction. So here we, in this slide, we saw that there is a huge amount of consumption of concrete these days, and it is second only to water. Then we saw a brief history of the evolution of reinforced concrete buildings, starting from John Smeaton and his discovery of concrete, followed by the discovery of Portland cement, and then Joseph Monier and the Hennebick system, which is very close to the present reinforced concrete construction. Then we also saw some of the historical structures which have been constructed using reinforced concrete. For example, the Roman Pantheon, which was constructed using reinforced concrete almost 1900 years back, and it is still standing, which is testimony to the durability of concrete as a construction material. Then we discussed the bending stresses in a beam, what happens when a beam is subjected to flexure, how it is subjected to compressive stresses and tensile stresses, which is separated by this layer of neutral stresses, which is also called as neutral layer or neutral axis. Then we saw the Hennebick system, which was developed by a French engineer. Then we saw that concrete is essentially poor in tensile strength, and it must be combined with steel in order to attain the desirable tensile properties. And then we saw how both of them are compatible with respect to the thermal expansion coefficient, which makes it a very useful material for construction. Then we saw the different components or the elements used in reinforced concrete construction. For example, the load is initially applied on the slabs, which is then distributed to the beams and further to the columns, and then it is eventually to the lower story columns, followed by the foundation, and ultimately all the forces are transmitted to the soil. So then we looked at the different systems, such as this is the flat slab system. Then we saw the gravity load transfer and the lateral load transfer. So essentially in the analysis and design of a building, the gravity load elements and the lateral load elements are considered separately, and it is going to be discussed in the future lectures as to how to consider their design. So then we looked at some of the very interesting structural system on which the present reinforced concrete construction is based. So we started with non-rigid frame, then followed by rigid frame, then braced frame, and outrigger trusses, tubular systems, and so on, which helps us to achieve reinforced concrete buildings of greater and greater heights with enhanced stiffness. Then we looked at the structural system which is underlying some of the most prominent structures, such as the Burj Khalifa, which involves a tubular system, and then we looked at the Petronas Towers, and which involves a tubular structure with shear walls and concrete frames. Then in our own country we have the World One Towers. Then we have, apart from buildings, we have other engineered structures also, such as the Bandra Worli Sea Link and the Sheikh Zayed Bridge, and so on. So all these forms of construction is made possible because of the properties that reinforced concrete possesses. And then we looked at the hydraulic structures also, such as the Gordon Dam and the Bakra Nangal Dam. So here we discuss some of the advantages of reinforced concrete in comparison to other construction materials, such as its higher compressive strength, greater resistance to fire and water, and higher rigidity and long service life. So most of the structures have been able to sustain all these years because of the long service life that is being presented by the reinforced concrete as a material. Then we looked at some of the disadvantages also, such as the necessity of providing tensile reinforcement in order to make the structural elements sufficient under tensile stresses. Then formworks are an important part of the construction, which can increase the time taken and also the costs by a significant margin. Then, as I discussed, we are able to combine concrete and steel in order to develop reinforced concrete, because they possess similar thermal coefficient, as a result of which there will be no residual stresses, and their mutual compatibility is a boon for the reinforced concrete industry. Then we looked at the sustainability aspect, that how buildings contribute to 36% of the total energy consumption. So a lot of energy is being dispensed in the manufacturing of raw materials and during the construction process. So most of you might be aware that we need to limit the global warming by 1.5 degrees Celsius by the end of this century. So in order to it is very essential to incorporate the practices of sustainability in our construction industry, so that we can contribute to a greener planet. So this is the embodied energy, and concrete compares very well in terms of the energy that is taken compared to steel and aluminium. Then we looked at the trends of the energy consumption, and we also looked at some of the other alternatives such as the geopolymer concrete, which can reduce the emissions and help us attain our sustainability goals. So in summary, we saw the evolution of concrete, then the different structural system, advantages and disadvantages of reinforced cement concrete, followed by the sustainability issues. So I hope all of you are with me so far.
Yes, sir.
Yes, sir.
Yes, so I will quickly take up the second part of the presentation also, and if you want me to go slow, please feel free to interrupt, and if you're not understood any concept also, kindly feel free to stop me there and we can have a discussion and resolve it there itself. So I hope the presentation is visible now, the second presentation, I mean the second part of the first module. Hello.
Yes, sir.
Yes.
Actually, I am not getting the presentation, sir. Only this blank is coming.
Okay. No, but I think others are able to see, right? Okay. What I can do is yes, I will just stop sharing and I'll share once again.
Maybe the participant has to disconnect and join again. Yours was visible, I think.
Okay,
Yeah.
sir. Okay. Okay. So is my slides visible now?
Yes, sir, it's visible.
Yes.
Yes,
So
sir.
okay, perfect. So we'll go ahead. So after the introduction to reinforced concrete as a material, then we looked at some of the design concepts which we'll be using in the upcoming lectures. So first we understood what are the objectives of structural design, followed by the need for design codes. Then what are the different types of concrete designs? What is the difference between analysis and design? Then what are the different design methodologies? So over a period of time, there have been different design methodologies that have been evolved in order to help us in the design of reinforced concrete structures. Then we have looked at the difference in the design philosophy between the ACI, that is the American code, and the Indian code. So these are some of the objectives of structural design in order to ensure adequate strength, stability, serviceability, durability, and economy and aesthetics. So we'll be discussing in detail about these aspects such as strength and stability in the upcoming slides. Then these are some of the aspects of structural design we need to consider. That is, it has to be functional. We have to take into consideration the functional and safety aspects. Then we have to perform our design in certain constraints. Further, we need to follow a certain procedure in the reinforced concrete design. Then we need to take into account the different stakeholders, so that ultimately we are designing a building for the owner or the person or the people who are going to inhabit there. So we need to work in an integrated way in order to ensure that the objectives for which the building is being constructed is being served. So here we can see that there are different types of structures which have been designed, and we need to take into consideration all these aspects. However, the contribution of one factor can be different for the other. For example, for nuclear power plant, we see that it's a very important structure, so the functionality and structural adequacy become important aspects, whereas the economy can be overlooked to a certain extent. And these are some of the codes that we have. So for the reinforced concrete in India, we have IS 456, as all of you know, and IS 1893 for the earthquake resistant design, and for the pre-stressed concrete we have IS 1340. So these are some of the um, uh, factors why the design codes are required. Then we have the different types of concrete design. We have essentially three types of concrete. One is the plain concrete. Concrete is generally very rarely used in actual practice because of the lower tensile strength that it possesses. However, reinforced concrete design is what we're going to be covering in this particular course. Then you have the pre-stressed concrete, which is a very interesting material.
Excuse me, sir.
Yes.
Sir, generally, where we use plain concrete, like in construction industry, or why we
So
construction
so plain concrete is
residential or
yeah, plain concrete is very limited in its application wherever like we are not expecting tensile stresses to develop. So we can say that its application is considerably less compared to the other two forms of um, concrete design.
of
Yes,
services.
yes.
Generally, these are, typically used in stubs, predominantly compression members. Okay. When you know that absolutely it is not going to have any tension, then plain concrete can be used. Okay. And especially in bridges or, sub-base courses, even in slab on grade applications, we put reinforcement only for, temperature and shrinkage. But otherwise, for structurally requirement, we don't really put any reinforcement. Okay, such some very limited applications are there where even before foundation comes, sometimes what happens is we put this a simple layer of PCC, right? So for such kind of applications where
Yes,
predominantly
sir. Yes.
compression, we will use this. Yeah.
Yes. Thank you for clarifying, sir. Yes. I hope my screen is visible. We can go ahead with the slides.
Yes. Yes. Please.
Yes, yes. So we have pre-stressed concrete where the members are pre-stressed to a certain degree, which makes them eligible to take up the tensile stresses. So we use, instead of reinforcing steel, we use these tendons in order to induce uh, stresses within the pre-stressing within the members. So then we have the concept of design versus analysis. So analysis is essentially the process of determining the stress resultants such as the axial load, shear force, and the bending moment, and the displacements. However, the design is to determine the cross section and the reinforcement and the structural detailing in order to resist these stress resultants. So moving forward, we have the design methods such as the working stress method, then the ultimate load method, and the limit state design method. So these we will be covering in greater detail in the questions that I have formulated today. So then we have the probabilistic analysis and design, which is the basis for the limit state method of design. So here we account for the variability in the loading and material properties, and the variability tends to follow a normal or a Gaussian distribution, and all our partial safety factors have been adopted based on uh, the the distribution that it follows. So we have the characteristic load and the characteristic strength. So we need to always ensure that the strength is greater than the demand. So some discussion on the partial safety factors. So we have certain limit states, we have certain ultimate limit states and the service limit states, serviceability limit states. So we'll be looking at these aspects in more detail in the upcoming questions. So these are some of the differences between the ACI code and the IS code. So ACI code is based on the load and resistance factor design based design approach. However, the IS code is based on the partial safety factor method. So the ACI follows different strength reduction factors for different types of failure. However, the IS code follows a uniform partial safety factor. So this is one major difference between these two approaches. So in the second part of the first module, we looked at structural design and the factors that needs to be considered, followed by the necessity for the design codes. Then we looked at the different types of concrete design. Then we looked at the background to the different design approaches, namely the working stress method, the ultimate load method, and the limit state method, and how the theory of probability can used in the limit state design. So I hope we are ready to start with the multiple choice questions.
Sir, one question.
Yes, yes, please.
Sir, I am asking like while we are construction like bridges and dams or heavy like nuclear plant, generally we were using like designing with WSM.
Okay.
And while we construction residential, why we use LSM, why we not using those LSM design
Okay.
like in bridges construction or dam construction.
So to my knowledge, the basic difference between the working stress and limit state method is that the factor of safety is more on the conservative side for working stress method. But I would like to add that all the present structures, they are mostly based on the limit state design only.
Yeah, I think that you're absolutely correct, Lalit.
Yes,
Just
sir.
to add on,
Yes.
see, even bridges now are designed using limit state method only. So working stress method only in certain cases, like special structures like water tank, you are allowed to use working stress. Or the serviceability condition will, determine the design. So that controls the design. So serviceability condition. But otherwise, all the design codes are based on the philosophy of limit state design only. Okay, and even steel structures before 2007 we were using allowable stress method, but even there they have now switched to limit state method. Okay.
Okay.
As Lalit said,
Thank you,
yes,
sir.
as
Yes,
Lalit
yes.
said exactly, the factor of safety is much higher, but the factor of safety is not uniform, as explained in some of the videos. Here, it's much more a rational approach. You also take care of the variability in the loading. You also take care of the variability in the material properties. So, in a much more rational way, in a probabilistic sense. That is the reason it is more advanced method which is adopted by the courts all over the world. Yeah.
Yes. Yes, sir. Thank you, sir. So we are going to be starting the question and answer session. So there are 15 questions. So I hope we'll try to make it a very interactive session, this one, and I hope you enjoy the questions that has been prepared. So what is the role of transverse steel ties in reinforced concrete columns, and select multiple options. Can any one of you volunteer? Hello? Hello? No, you can unmute. You can unmute and you can answer, please.
It's B.
Okay, so there are multiple
Maintain the
options.
positioning launch.
Oh, there are multiple options. In fact, there are three correct options. Yes, B is also one of the correct answers.
Majorly it is used for that.
Yes, yes.
Hmm.
So there are two other options which are correct.
C is wrong.
Yes, C is incorrect. Any one of you would like to add your comments?
So can you clarify why it? How does it increase the compressive load carrying capacity?
Okay. Okay. So the answer is, as one of the participants mentioned, it is all the other options apart from C. So the answer is A, B, and D. So the explanation is thus. So for a reinforced concrete column, as you can see, it consists of the longitudinal rebars, then it consists of the stirrups, then it has the concrete. So first is correct because it helps the longitudinal rebars to stay in their original position. Then it thereby it prevents the lateral buckling by reducing the effective length. Then it helps in maintaining the position of longitudinal bars, and the transverse ties are do not have a direct influence on the flexural strength. However, the confinement option is correct because when you provide these loops around the cross section, it leads to an effect of confinement, as a result of which the compressive strength of concrete is enhanced. So if you test two specimens, one without the stirrups and one with the stirrups, so the stirrups tend to provide a confining effect, and subsequently the actual the compressive load capacity is higher. Okay, so I think we can move on to the next question. Which of these statements clearly brings out the difference between structural analysis and design? Anybody would like to volunteer?
Sir, option C.
Yes. Anybody thinks that other option is correct? Okay, anybody else would like to answer? Confirm the answer. Okay, so I'll go ahead, and the correct answer is C, and the statement is self-explanatory. So as we already discussed in the review of the presentation, structural analysis refers to the determination of forces or the stress resultants and the displacement in structural members. However, design corresponds to the provision of adequate member sizes. And Here in option B, the provision of structural member layout, that is what is called as a planning. So that comes earlier to the process of analysis. And then statement D is right to some extent, because analysis and design are interdependent, because initially you take a particular dimension of the cross dimensions of the structural members such as beams and columns, let's say 250 mm width and 400 mm depth, and in the analysis it is found out that uh, uh, the the forces are very high, so we have to modify the design accordingly. So this statement is partially correct, but option C is the best answer. So we have to remember that the structural analysis and design are cyclic and iterative processes in order to obtain an efficient structural design. So we can move forward. So we discussed about the Hennebic system of construction, uh, which was developed approximately in 1890s. So identify the correct statement among these four statements. Anybody would like to volunteer? Anybody would like to?
Sir, not sure, but I think so.
I'm sorry.
Sir, I think so, B, sir.
Okay. I hope my connection is clear, stable. Hello. Anybody would like to volunteer? So the correct answer is C. Sorry, B. B is the correct statement. Hello. I hope I am audible.
Yes, sir.
Sir, yes.
Yes,
Yes,
sir.
sir.
Yes, yes. Was the connection not stable in between?
It was stable, sir.
Okay, okay, okay. So, as I was discussing in the initial slides, Hennebic system was introduced by a French engineer. So he patented his pioneering design for reinforced concrete, not pre-stressed concrete. So pre-stressed concrete came much later, at around I think 1930s or something. Um, and in United Kingdom, the first building to be constructed using the Hennebic system was the Weaver building in 1897. So this was the correct answer. Then statement C, Hennebic system of construction varies considerably from the modern day reinforced construction. This is wrong, because the Hennebic system is very much similar to the modern day RC construction. Then Hennebic system was discontinued in practice as it was considered as inefficient. Again, this statement is wrong, because Hennebic system is the basis of the present day reinforced concrete design. So despite of the system being introduced almost 125 years ago, so this laid the foundation for the present day reinforced concrete construction which is happening so vastly as we know. So I hope all of you are with me.
Yes, sir.
Yes. So if there is any question, kindly feel free to interrupt. We can have a discussion. Yes, can we go ahead? Am I audible? Hello?
Yes, it's audible.
Yes. Okay. So I have given this Wikipedia link, for you to explore more about this Henipic system. So we have this question on flat slab system of construction. So in the flat slab system of construction, we saw something called as the column capital and the drop panel. So the question is, what is the purpose of providing column capital and drop panel in flat slab system of construction respectively, because each of them have different functions. So what is the purpose of providing them?
Sir, B1.
B, is it?
Yes, sir.
Okay.
I think.
Okay, anybody else would like to try?
D option is correct.
B? I think
Yes,
most of the participants
sir.
are
B.
saying B.
I think yes, sir.
Sir, option A.
Okay.
Option D.
Okay.
So basically, it's into the like a specifically view of a building. So that I think so.
Option A.
B is the answer. Sir.
Okay. So the correct answer is actually A. So the explanation is that the column capital, it is essentially has a greater cross section. So this improves the flexural and shear capacity of the column due to a higher cross sectional area. And then the drop panel, which is like a small protrusion from the slab, it improves the shear capacity because of the increased slab thickness. So I would like to just show you again the diagram of this flat slab. Okay, I think it's in the second one. Or probably it's in the first one. Yeah, so I hope the screen is visible now. So we are looking at a flat slab system. So this is the column.
Yes, sir. It is.
Yes, so this is the column capital, which has a higher cross sectional area compared to the rest of the column. So it is sort of flaring out in terms of the area. So this area helps in providing greater moment and shear resistance for the column. And then this particular part is called as the drop panel. So as professor mentioned in the lecture, so there is a scope for punching shear. So beam is designed in order to resist the force coming from the column, but the slabs can be vulnerable to punching shear because of the concentration of the axial force. So this drop panel, by providing a higher depth, it helps in improving the shear resistance of the slab. So the correct answer is supposed to be option A, that is the column capital helps in improving the flexural and shear capacity, and the drop panel helps in improving the shear capacity. And option B is incorrect, and option C was provided just to confuse you. And option D, in fact, we are able to achieve a higher floor height. I mean, we are able to decrease the floor height, and as a consequence, we are able to provide more number of stories. So, for example, if we consider uh, for a height of 60 meters, if we are able to provide a 20-story building, so we can actually provide 21 stories because we are not going to provide beams as such. So flat slab system helps in improving, helps in adding additional stories in a structure.
Sir, column is not designed for flexural, na?
No, column is designed for flexure also.
But
See,
at slab and column junction,
yes,
how it if at junction, how is the flexural design is there at
yes.
the junction?
See, when you analyze a building, so basically there will be member end moments, right?
Yes,
So basically there are three forces that you have to consider. That first is the axial force, second you have the bending moment, then you have the shear force.
yes.
So actually when you compare to other parts of the member, other parts of the column ends tends to have a higher bending moment. So accordingly we need to provide the longitudinal reinforcement correspondingly.
Okay.
So this type of structure is it applicable for like the construction like 20 floor buildings, D plus 20?
No, I was just giving an example, but for 20-story building, you need to have a framed structure. So what I was trying to say is that this helps in
Yes, sir. Because like
yeah.
yeah, yeah. Okay,
So
sir.
I can try to explain the previous one using just give me 1 second. So I hope my speed is all right. Do I need to go slow or faster? Kindly comment on that.
It is adequate.
Okay, thank you. So let me. So the previous question, one of you asked that. I'm sorry. Yes, so one of you asked that if you consider portal frame, excuse me, this is a bit difficult actually to control. So if you consider UDL, so definitely, and if you consider some lateral forces, probably because of earthquake or wind loading, it can be of any magnitude. So essentially, if you take the free body diagram of the column, if you separate the column, so you will have to consider three forces. So and yes, apologies for my illustrations once again. So this would be the shear force, this would be the bending moment, and this will be the axial. So whether it's a flat slab system or it is a framed system, we need to consider these three forces when we are performing the reinforced concrete design. So I hope it is clear. A participant who asked the question. Hello.
Yes, yes.
Yes. Yeah. So we can move on to the next question. We have another 11 questions. I hope you are enjoying this. Oh, I'm sorry. Okay, so this we have a numerical problem which we are going to solve right now. So you have a frame, symmetrical portal frame ABCD with columns 4 meter height, fixed at the base points A and D, and the beam BC has a span of 6 meters, and it supports a UDL of 100 kilonewton. So after the analysis, it has been found that the reactions are 50 kilonewton, 30 kilonewton, and 40 kilonewton. So with the help of a free body diagram, can you determine the design bending moment and shear force for the beam BC? Can any one of you take a pen and paper and quickly solve the problem? I will try to make an illustration so that it is visible for all of you, just to make you understand. Oh, we could have kept that frame. Okay, so what we are looking at is so this is 6 meter, the length of the beam is 6 meter and the height of the column is 4 meter. Let's say it is A, B, C and D, and it is subject to a combined cumulative load of 100 kilonewton, and can any one of you try to solve this problem? So I hope some of you are trying to solve along with me. So in this problem we have to determine what is the bending moment at B. So if we find out the MB, so that will give us the answer. What should be the bending moment for the beam? So we'll take a moment about point B, that is sigma MB should be equal to 0. So if you take minus 40 into 4, I'm sorry for the messy handwriting, consider anti-clockwise again, minus 30 plus MB is equal to 0. So MB has to be
into 4.
yeah, I'm sorry, I think it has to be 30 into 4, no? 30 into 4 and 40, I think. Yeah, 30 into 4 and 40. So if you do the calculation, it comes up to 80 kilonewton meter. So you can verify it once again. And the shear force would be 50 kilonewton. So yes, so the correct answer would be option D, that is 80 kilonewton meter and 50 kilonewton. So I'll be sharing this slides with you, so you can work it out at your home and ascertain yourself that you're getting the answer. So we can move ahead, I think. Hello.
Yes, sir.
Yes.
Okay, sir.
So which of the following elements are provided for resisting lateral loads? So we have to select multiple options for this particular question. So essentially there are two types of elements, that which resist the gravity loads and those which
The top line is not clear.
I'm sorry.
Okay. Top line is not clear actually. Okay, sir. Nice.
Okay. So option A, shear walls, load bearing masonry wall, flat slabs and frame tubes. Any one of you can volunteer? At least
Sir, A. Shear walls. Sir,
Okay,
Sure, boss. Sure, boss.
A is correct. There is another correct option also.
Framed tubes.
Yes, yes. So the correct answer is A and D. So we have the shear walls and the frame tubes, and the explanation is that as I was mentioning earlier, in the structural analysis and design, the structural analysis and design, so the gravity and lateral load resisting members are considered separately. So the shear walls and the frame tubes are generally designed to resist the lateral loads. By virtue of their stiffness, they also resist the gravity loads, but they're essentially considered as lateral load resisting elements. However, the load bearing masonry walls and the flat slabs, they are essentially provided in order to resist the gravity loads. So flat slabs, as we saw earlier, they have very little role in resisting the lateral load. They simply exist in order to transmit the lateral load through diaphragm action. Okay, so moving on, what is the mean target strength required for the mixed design of M25 concrete, assuming moderate quality control? Sorry. So can anybody volunteer regarding this question? So I will give you a brief theoretical background, if that is okay. So essentially, we at the site we say that we require M25 concrete, right? So when you are actually casting concrete at site, we are also preparing some concrete cubes in order to test them in the laboratory and to ascertain that what M25 concrete that we are using, we are able to attain that much of strength. So in order to qualify as an M25 concrete, what has to be the mean target strength of those concrete cubes?
31.6.
Yes. Sir, who answered the question?
Yeah, my name is Gaurav Kumar Singh.
Okay. So you have experience of designing the concrete mix.
Yes, sir. I have experience for mixed design to prepare mixed design.
Okay. So that is the correct answer. So I would like to go ahead and provide the explanation. The correct answer is 31.6, and this particular question was actually outside the first lecture, but it was in the textbook of Pillai and Menon, which is a prescribed textbook. It was taken from that particular text, and the mixed design is generally prepared using the IS code 10262, and this was quite interesting because I was also not aware of this particular concept, because when we are quantifying a concrete as M25 concrete for a project, if we say that we want M25 concrete, so we are not going to stop at M25. So essentially we are looking at mean target strength, which is characteristic strength plus 1.665 times the standard deviation. So for this M25 concrete, we have a standard deviation of 4 megapascal. So using this expression, we obtain the mean target strength as 31.6 MPa. So in order to qualify as a M25 concrete, we need to achieve this mean target strength. So I suggest that you have a look at this IS code also, because this standard deviation is slightly different for higher grade of concrete. For example, for M30 concrete, it is M30 and above it is 5 megapascal and so on.
Sir, I have to say something.
Yes.
The IS code referred in the explanation is IS 10262 2009,
Yes,
but
yes.
it is revised in 2019 also. So
Oh,
now we use IS 10262 2019.
right, right. So, thank you for that input. We can incorporate that also. And I think the provisions are more or less same, or are there any major revisions that we should know? Sir?
Yes, sir.
Yes, yes. So, are there any major revisions from the 2019, 2009 to the 2019 version which you would like
Yes,
to
sir.
share?
Yes, sir. Yes, sir. In 2019 revision, many things were added,
Okay,
like the mixed design for flyers,
okay,
for slags, and for self-compacting concrete. Other
okay,
types of different mixed designs are added in 2019 version.
okay, okay. Okay, so thank you for sharing this with us, and even I will probably have a homework to do. I will go back and look at what are the differences between the 2009 and 19 version. So, moving on to the next question. So, what are the expressions for the modulus of rupture and splitting tensile strength of concrete? So, in the class we discussed that essentially the tensile strength is a percentage of compressive strength. Can anyone of you remember that? What percentage of compressive strength is the tensile strength of concrete?
Sir, 8%
Yes,
to 15,
yes. So it is 8 to 15%.
8 to 15, I think so.
Yes,
Or the answer is, yes, sir, the answer is, I think so, 0.7. F is the under root F sitting. Maybe, child.
okay, okay. So we can go ahead and say the answer. So the
A.
yes. So as some
Answer
of
A.
you pointed out, answer A is the correct option.
Yes.
And the explanation is that practically it is difficult to obtain the direct tensile strength of concrete, as it is difficult to apply pure tensile load free of any misalignment and secondary stresses developed at the grips of the testing machine. So, how we test the concrete cubes under compression using UTM machine? So, in a similar manner, we cannot capture the tensile behavior adequately. So, for example, if we are testing cubes of strength 25 MPa, it might fail at a load of just 2 or 3 MPa. So, and it is extremely difficult to apply pure tensile load. So, we try to find out the indirect strength of concrete under tension using this modulus of rupture and splitting tensile strength, and some of you might even remember from the slides. I'll have to go back, I think. Yeah, so what you see here is the flexural test. It's a 3-point bending test, and the strength at which it ruptures in tension is called as um, the rupture strength, the modulus of rupture. And in splitting tensile strength, we are going to take a cylinder. So as you can see, we have a cylinder and we are going to apply a vertical load like this, and the load is the load if the load at failure is P. So we determine the splitting tensile strength using this particular equation, that is 2 pi by pi dl. So this gives an indirect estimate of the tensile strength of concrete. So this is plain concrete, just for your information, and we are not discussing about reinforced concrete. This is the strength refers to the plain concrete. Okay, moving on. So which of these statements best describe the design philosophy behind ultimate load method? So we discussed three types of design philosophies: working stress method, ultimate load method, and the limit state method. So I reserve the discussion for this particular question.
B.
Okay, one of the participant has said D.
No, sir, B, B.
Okay, okay, B for Bangalore. Okay,
So B.
okay. Anybody else would like to volunteer? So the answer is absolutely correct. Answer is B. So essentially the difference, the best statement is that the effect of loading is amplified but the material resistance is not reduced. So statement A refers to the working stress method, where the effect of loading is not amplified but the material resistance is reduced by a partial safety factor. So for concrete it is reduced by as much as 3. So if the compressive strength of concrete is 30 MPa, so we consider only 10 MPa. So in that effect we ensure that the structural elements are in the linear elastic region, okay, but the loading is not amplified. And the second statement refers to the ultimate load method, where instead of the material resistance we are going to increase the loading effect. For example, the strength of concrete is taken as 30 MPa, but the loading is increased by a factor of 2. So if we are expecting 100 kilonewton, we consider 200 kilonewton, and we are going to perform the design. And then statement C corresponds to the limit state method. So in the limit state method we are going to consider both the factors. So again I would like to take the help of this slide. So basically we have two aspects. So on the one hand we have strength. So on the one hand we have the strength, and on the other hand we have the effect. So the resistance, the resistance has to be greater than the loading effect in any of the three design philosophies. Okay, so that is what we are looking at. So in the case of the limit state method, we are going to increase the loading effect also, and we are going to reduce the material resistance by a suitable partial safety factor. And D is an incorrect statement which does not correspond to any of the design philosophies. So moving on. So what is the difference between deterministic design and probabilistic design?
C.
Okay, any other answers?
So A.
Okay,
A. A.
okay, any other answers? Okay, so I will show the answer now. So the correct answer was C, as one of the participants rightly mentioned. So the explanation is this. So in the deterministic design, safety margins in terms of permissible stresses and load factors are determined using engineering judgment. So earlier we spoke about the two different. Excuse me, I'll take the help of this to better explain, since some of you had issues answering this one. I request the participants to mute their microphone. So as I was telling, we have the working sorry. Okay. Okay, and we are ready. So we have the working stress method, and then we have the ultimate load method. So if we are taking S as the loading effect and R is the resistance, and similarly here also we have S as the loading effect, R is the resistance. So in working stress method, we are we are reducing the R factor by considering partial safety factors such as 3, whereas this is not affected, right? And in the ultimate load method, the resistance is not affected, but we are considering the loading effect amplified by a certain factor of safety. So let's say, for example, we are amplifying by a factor of 2 or 3. So how are these numbers coming up? Anybody knows? So these numbers are purely based on engineering judgment. So nobody has told us that you have to consider 2 or 3. It is only you can say by an empirical knowledge they were building they were building structures, and the structures turned out to be safe. So there is no rational basis in order to adopt this safety margins. So both the working stress method and the ultimate load method are considered as deterministic design. However, the limit state method, which is currently we are following, that is based on a rational basis, that is the probabilistic theory. So the partial safety factor that we are considering, so that is based on probabilistic theory, and it is not merely based on engineering judgment. So answer C is the correct option, that is WSM and ULM are based on deterministic theory and LSM is based on probabilistic theory. And this statement is incorrect because either the probabilistic design or the deterministic design can give conservative outcomes, so it differs from case to case. So I hope all of you are with me. So we have another 5 questions to discuss. Okay, so I think we can go ahead now. Yes, moving ahead. We'll try to wrap up by 9 o'clock. Okay, limit state of serviceability does not include which of the following conditions?
A.
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 Okay. Any other volunteer to confirm the answer?
B.
I think it's B, sir.
Okay.
C.
Okay. So we are going towards the wrong side actually,
B.
because limit state of serviceability,
But
many of them are not included. So we have to select that which does not represent the serviceability conditions.
A.
Okay, so initially I think you gave the right answer, but I encourage all of you to participate. Whether it is right or wrong, we learn through mistakes. So I also learned a lot during the course of making this PPT. So I encourage all of you to participate, and the correct answer is A, because the crack width, undesirable vibration, and excessive deflections all corresponds to the limit state of serviceability. And the explanation for this is that the instability caused due to buckling comes under ultimate limit state or limit state of collapse. So as professor discussed in the lecture, the structures are essentially designed for ultimate limit state and their performance is checked for limit state of serviceability. For example, if you're designing a beam, for example, as we did in one of the earlier questions, so here we considered the loading effect, right? So we are going to design for these forces, that is this bending moment and this shear force. And once you design based on the ultimate limit state or the limit state method, then we are going to check for the limit state of serviceability criteria, that if a beam is able to maintain its crack width below a particular level, or it is able to avoid undesirable vibrations, or if it is within a given deflection limit. So in essence, we are going to design structures for limit state of collapse, and we are going to check them for limit state of serviceability. So moving on, question 12. So this is a very interesting numerical question. I hope you can understand. So to simplify, we have different load cases: dead load, live load, wind load, and earthquake load. So for the maximum moment corresponding to dead load is 50 kilonewton meter. Maximum moment corresponding to live load is minus 80 kilonewton meter, and wind load is plus or minus 120, because the direction of wind load and earthquake load can be reversed, and for earthquake load it is plus minus 180 kilonewton meter. So these are for particular load cases. We have to determine the ultimate design moment for the limit state of collapse considering the load combinations. So most of you might be aware that we consider load cases separately, but we are performing the design. We are going to design for load combinations. So this is a very I think hands-on kind of a problem which we even encounter when we are designing buildings. I think one of the participants was asking for a live example, so this is one step towards that. So anyone wants to try? So I can give you a hint actually. So these are the different load combinations that we consider. So we have 1.5 dead load plus live load, then we have 1.5 dead load plus wind load. So we have different kinds of load combinations. So I think when I circulate, probably you can attempt this question. So in order to solve this question, what I did was I created an Excel sheet. So I have considered dead load, live load, wind load. So these are the corresponding maximum bending moment. These are the load combinations that I considered: 1.5 dl plus LL, 1.5 dl plus WL, 1.5 dl minus WL, dl minus EL, dl minus 1.5 WL, minus 1.5 EL, and here I have considered minus WL and minus EL. So please note that wherever we are facing WL or EL, we are going to consider both the positive direction and negative direction. So of all these load combinations, you have to consider the most severe loading effect. So the most severe loading effect turned out to be plus 225 kilonewton meter, that is sagging, and minus 372 kilonewton meter for hogging. So correspondingly, this is the answer. I hope it is clear for the participants.
Yes, sir.
Okay. So there are 3 more questions. Without further delay, let's go ahead. So which of these statements best describes the concept of code calibration? I think those in academics or industry, you might have come across this term. Have you? Code calibration or calibration of codes?
No, sir.
Okay, so it is a very important concept. You should try to attempt this question. You can.
D.
Sorry?
D.
Okay, D. Okay. D for Delhi.
Yes, sir.
Okay, thank you for your response. Anyone else likes to try?
Option B.
Okay, B for Bangalore. Okay, thank you. Anybody else? Okay, so I think we'll go ahead with the answer. The correct answer is D, as one of the participants rightly pointed out. Sorry for that. It has to be D, and the remaining options were just taken from the internet to confuse you. The process of making sure materials used in construction, that is incorrect statement. So the process of evaluating performance, it is called as structural auditing. I think some of the people in industry might be knowing, might have heard about that term. And the process of comparing codal provision, it is a fictitious statement. It is not true. So the correct answer is D. So the probability of failure. So the safety factors that we are using, the partial safety factor or the strength reduction factor, so these values are based on the reliability index and probability of failure. So these have to keep on updating. As you know, more and more data becomes available to us. It will have a significant effect on the safety factors. So as the research activities advances, in the lecture you might have seen that there are 3 levels of reliability. So what we are dealing with is essentially reliability level number 1, but as we perform more and more research regarding this reliability, we can attain at a better estimates of values of the partial safety factor. So code calibration corresponds to statement D. moving on. So based on the ACI code, which is based on the LRFT method, for the axial load, which is the strength reduction factor. This has been taken up directly from the lecture slides. Any one of you can volunteer. Hello.
C.
Okay. Okay. Okay, so it is a straight direct question from the slides, lecture slides. So the answer is B. So we need to focus on the term axial load. Okay, so because in the Indian Standard Code, we follow a uniform partial safety factor for member strength, whether we are designing for moment or shear or axial. But the LRFT method, which is based on the strength reduction factor, as and when we go towards the more brittle mode of failure, that is shear failure and axial failure, we tend to reduce it by a higher margin. So if the actual strength, if the theoretical strength is 100 kilonewton for a column, we consider only 65 kilonewton or 70 kilonewton as its design limit. Moving on to the last question of this live session 1. So what is the strain in Fe 415 steel corresponding to a stress of 0.87 Fy?
A.
Okay, thanks for the response. Anyone else would like to volunteer?
C.
Okay.
B.
D. Okay.
B. B.
B.
B.
B.
Okay. Okay, so I'll provide the answer. The correct answer is C, and the explanation is this: the strain corresponding to a stress of 0.87 Fy is given by 0.002 plus 0.87 Fy by ES, where ES stands for the Young's modulus of steel. So when you calculate, when you put the values of Fy as 415 MPa and ES as 200 GPa, that is 2 into 10 power 5 MPa, we obtain the value of 0.0038. So thanks for the response, and here our question and answer session comes to a conclusion. So okay, so I think we'll stop it here, and I would like to ask the feedback from the participants, because this was our first session. First of all, I'd like to thank all of you for joining this session and spending this discussion time with me. And if there is any feedback so that we can improve in the next session, I invite you to let me know how we can improve the next session.
So this is a very informative and good session.
Okay, you can turn on the video if it is fine. Yes. Yes,
This
please
is
go
very
ahead.
effective. This is very effective.
Okay,
an
okay.
informative session.
Okay, so is there any aspect, regarding the content, regarding the question and answer? Should I prepare more questions?
No, no, sir. This is very good
Okay,
and very knowledgeable session.
okay, okay. Thank you for joining. Anybody else would like to add?
Thank you.
So the lectures were very organized. Thank
Okay,
you, sir.
okay. Thank you. But if you want me to improve in any aspect, kindly let me know. And my request is, try to make use of this live interaction session to improve your understanding, because these are designed for you. And uh, Professor Surya Prakash and I, both of us will be available for you. And if you have any major concerns, then I will organize a live interaction with Professor Surya Prakash as I did today. So sir will be happy to join. So any feedback, any other comments, feedbacks?
Actually, it is general, sir. Some courses are clashing. Same time you are giving.
Oh, is it?
Um, yeah.
Okay,
On
which
30th,
course?
on 30th, there are 2, 3 classes are there, sir, actually.
Oh,
Um,
on 30th is
final
it?
element.
Oh, okay.
30, 30 July.
Oh,
30
okay, okay.
July.
No, but our session will be on Saturday. It will be held every Saturday at this time, same time.
So we have to same email, sir. Then actually, if I want any change,
Yeah,
it
yeah,
will be allowed or it
yeah, yeah.
is.
So I would suggest you to mail to the NPTEL coordinators, so they can uh, rearrange it accordingly.
Actually, we are getting online NPTEL courses, so email ID. So same we can apply.
Yes, yes. You should mail to the NPTEL the coordinators.
Okay.
Yeah, thank you. Any suggestions are welcome. I'm glad that all of you turned up for this discussion session. So your suggestions will be very helpful in further improving, and it will be designed according to your needs in the upcoming 11 weeks.
Just wanted to any problems any you provide that is okay, sir. No
Yes,
exercise
yes.
problems.
Yeah, yeah. Thanks for that feedback,
Mm.
because design course has to be based on numerical problems. So
Yeah.
since it was the first chapter was theoretical, it was based on, I think first 2 weeks would be like that, but first 2 3 weeks. But once we start, the design of axial members, flexural members, we are going to take up more and more problems. So I think more than 50-60% of the problems will be based on numericals only. So yeah, thank you for that feedback.
So this video will be shared, sir.
Yes, this will be uploaded on YouTube and NPTEL. I'm going to share it to the NPTEL team, and NPTEL team is going to share the link to this video on YouTube. So all of you can are welcome, and I'll be sharing the presentation also. So I'm very glad that all of you could join, and I hope that all of you and even more of you can join in the upcoming weeks. So if there is no further comments, I'd like to end this session.
Sir, sir, I just wanted to understand.
Yes.
Actually, I am from hydraulics background.
Okay. Yes.
I wanted to understand this course will be more oriented towards buildings or some structures like bridges and dams will also be taken into consideration.
Yeah. So we if you go to the NPTEL homepage, there is outline of all the 12 chapters, what we are going to discuss in the next 12 weeks. So this is based on structures. Is more precisely building structures. So we'll be not looking at hydraulic aspects, hydraulic structures aspects.
Okay.
So, but professor is planning to take some additional topics in the last 2 weeks or so. or he'll be floating a new course altogether. So I request you to keep an eye for that.
Okay, sir.
Sir, I want to take some suggestions for PhD work from you.
Okay, so we can discuss that in the offline platform. So that
Yes,
so I
yes, sir.
think I'll put my email ID on the chat
Yes,
box.
sir.
Yeah. So
Yes. Okay, sir.
so
Okay. Thank you,
my
sir.
suggestion is, like, I'm not able to see the chat, so whatever discussions you have, kindly feel free to unmute yourself and participate in the discussion. So this is
Okay, sir.
my Gmail ID. So if you have anything, yeah, you can feel free. You can mail me, and we can fix a time, and we can mutually discuss. Yeah, so if there is no further clarifications, comments, I would like to end this session. Again, thank you all for joining the session, and I hope to see you with more interesting questions and enriching discussions in the next week. Thank you one and all for
Thank you,
joining.
sir. Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.